In this video, I'm going to show the basic use of Mathematica. Mathematica is a computing environment which differs from other programming languages in that it has rather a different syntax. So I'm going to launch Mathematica again using this OS X desktop, a Macintosh desktop, but the environment you will see is quite similar to what you will see on Linux or Windows, which are the other two operating systems that Mathematica is available on. And I can hit Command Space, I can type in Mathematica, I hit Return, and of course I've previously installed Mathematica, and I will get this window that appears. Now, this tutorial will apply to most recent versions of Mathematica, by which I mean versions 8, 9 and 10 and the various subversions within them. So this particular version of Mathematica I'm showing here, if I go to About at the top left, you'll see this is Mathematica version 10.3, which I think is the latest one right now. And when you open Mathematica, this version of it, you'll see a dialog box that shows some recent files that I've been working on. I can sign in to the so-called Wolfram Cloud, which I'm not going to share in this video. What we're going to do first is we're going to open a new document, and that appears, as you can see. And I'm presented with what's called a notebook. Now, a notebook is a little bit like an integrated development environment in that it's an area in which I can perform calculations. And as you can see, there is a blinking cursor here and a horizontal cursor that I can click on. And if I sort of click anywhere around that area and type 2 plus 2, you can see that I can enter a mathematical expression. Now, if I wish to evaluate the expression, one thing that's different to Mathematica compared to other languages is I don't hit return. If I hit return, you can see I create a new line, and what's appeared on the right-hand side is this little box. This box is called a cell in Mathematica, and this cell enables me to enter several lines of expressions or code prior to evaluation. I'm not going to do that right now. I'm going to hit delete and go back one. You can see that cell has appeared. And there are meanings for the little hieroglyphic we can see on the right here. They're about what are called evaluation options, but we won't worry about that for now. So in order to execute this line of code, I can hit either the Enter key, which on some keyboards is on the lower right-hand side, or I can press Shift Return. And when I do that, you can see that some stuff appears. And this stuff at the bottom may vary depending on which version of Mathematica you have, but this bit up here, the in and out indicators, they indicate which calculation I've just carried out. So this is the first calculation. I've evaluated 2 plus 2, and of course I get the number 4 as the result. And again, you can see there is this cell delineation on the right-hand side. So those two expressions have been somehow encapsulated into a single cell. And I can do other calculations like 3 plus 3, and so on. I can do most mathematical calculations. Here's 2 times 6, 1 divided by 3. Now that looks a little bit different, doesn't it? So this is something which is not unique to Mathematica, but which is unusual in most programming languages. You can see that when I've asked for 1 divided by 3 to be evaluated, it's given me something which isn't a numerical, a floating point value. It's given me a fraction. So an exact value has been calculated. And this is something specific to Mathematica. So those are the basic arithmetic operations, and as you can imagine, most of the others are available. But let's look at some inbuilt functions. We're going to, as usual, look at trigonometric functions. Let's look at a trigonometric function like the sine of an angle. Now, something which is different in Mathematica to other programming languages is that I have to enter a square bracket around the argument. So let's try 30, see what that does. It gives me sine of 30. It returns the same value that I entered. What does this mean? Well, what it means is that Mathematica is preserving the exact value of the calculation sine of 30 until I specifically request a numerical value. And this is the same as in the division expression above. The exact value has been returned, and if I wish, I can display that as a floating point approximation, as a numerical approximation. The same thing is true if I evaluate sine of 30. Now, because Mathematica is calculating the argument, it's assuming the argument is given in radians, this is 30 radians rather than 30 degrees. So it is not an exact value. So let's look at how we can see the numerical approximation of these values. Let's type n of 1 divided by 3. And if I do that and I hit enter or shift return, I can display the numerical approximation to the exact value 1/3. Now I can interrogate what syntax I can use in this function n by typing query n. And you can see that it's downloading some help information, and it gives me two different syntaxes that I can use when applying the function n to some kind of input. And that input is given the word expression rather than the word argument. This is the way that it's done in Mathematica. And you can see here that I can ask for n digits of precision if I wish. So obviously Mathematica has a default level of precision, which is shown above, but I can ask Mathematica to deliver n to a greater level of precision. So I can ask for 1/3, and I can ask for 10 decimal places instead of the default. Or I can ask for, if I ask for n of 1 divided by 3 to 100 decimal places and hit enter, I get 100 decimal places. Now this is something that is not possible in most programming languages. You can see that I can actually ask for an arbitrary degree of precision. So let's go a little bit silly and ask for 10,000 digits of precision. And there we are. So you can see in the output, there's a continuation character on the right-hand side there, but you can see that Mathematica has calculated the value of 1/3 and given its numerical approximation to 10,000 significant figures, which is pretty cool. Let's have a look at sine of 30. I'm going to calculate now the numerical approximation to the sine of 30. And you can see that I enclose the argument to the sine function in square brackets, and again I enclose the argument to the n function also in square brackets. So whenever I have an argument for a function, or an expression that goes into it as the argument to a function, it's always given with square brackets. And I'm going to ask for that with no extra definition of the number of significant digits. I hit return and I get minus 0.988. And similarly to what I had for 1/3, I can ask for 100 digits of precision, and I can ask for 1,000 digits of precision, and I can ask for 10,000 digits of precision. Now notice what I did there as well is I changed the value that was entered into this cell. Now notice if I remove one of the zeros and ask for 1,000 digits of precision, see what's happened there. Firstly, when I type in the 0, Mathematica is helping display the numbers by grouping those zeros in groups of 3, which it will do for any groups of 3 digits, which is a nice feature. I can delete one of them, and I can hit enter, and now I have 1,000 digits of precision. And notice that when I did that, each time I did that, this number here is incremented by 1. This is important, and we shall see why that's important a little bit later. Another thing you will notice when applying any of these functions is that all Mathematica functions, all the inbuilt ones, are defined with a capital letter. All functions in Mathematica start with a capital letter, and in pretty much all of those functions that you will find, all the inbuilt ones, there are sub-functions, there are sort of longer named functions where subsequent sections of the word are also given with capital letters. Again, we'll see that a little bit later. Now, as with other programming languages, there are various reserved words and constants defined. Let's ask what pi is. Well, pi is repeated back to us with some form of scientific notation. So Mathematica will automatically convert various things that it sees in expressions into a more readable mathematical notation. And this is very handy. in many cases in terms of writing and reading code. Let's look at the numerical value of pi. There we are. The numerical value of pi is 3.14159. And just to convince you that we can calculate things very accurate with Mathematica, I'm going to calculate pi to 1,000 decimal places, 10,000 decimal places, and even 100,000 decimal places. And I presume this will take a little bit longer. So I hit enter, and it's pretty much instantaneous. So there we are. Pi is now calculated to 100,000 decimal places. I'm just scrolling all the way down to the bottom. So of course I can calculate more complicated expressions by typing them in. Let's say I want to calculate the sine of, let's type in pi, capital letters, pi divided by 2 plus cos of pi divided by 4, and I want to square that. So I'll put a square there and evaluate it. And you can see that Mathematica in certain circumstances will automatically simplify the answer where it can. It will make some assumptions about the values that it's given. So you can see here, because pi over 2 has a well-known value when put into the sine function, you can see that a very explicit value has been given. And notice that Mathematica has simplified this expression as much as it thinks it should do. So it thinks you want to see the exact value in the simplest possible algebraic form, so it will output 1 plus 1 over root 2 squared. And again, if I wish, I can copy that expression and I can ask explicitly for the numerical value of it by wrapping the n function around it, like so. So there you have it. There is how we do simple calculations in Mathematica. In the following videos, we'll show what the meaning of those little numbers at the start of the expressions are, and how we can do successive calculations in a notebook. A notebook being the thing that we've been entering all our calculations in so far.